Mana lagi tak boleh. Okay, it's okay. Today we continue with chapter 11, which is our last chapter, nuclear and particle physics. So this chapter basically can divide into three main topic. Kamu dah ready ke belum untuk kita start? I guess ready.
Ready je sir.
Ready je. Okay. So topik yang last ni dulu-dulu dia biasa separate tau. Chapter nuclear, chapter radioactivity, ada chapter. So for your syllabus, they are compressed and they combine everything. For today, I will try to focus on nuclear, okay, where we learn about mass defect, binding energy, and binding energy per nucleon. Nanti kita belajar lah one by one. In terms of calculation, for this chapter, it will only involve nuclear and radioactivity. The particle physics, there's no calculation. You only have to focus on theory part. Okay, to understand the chapter of nuclear, obviously you have to look into a nucleus lah. So this is an example of atomic model, okay, where you have a nucleus in the middle here. So dalam ni ada nucleus which consists of proton and neutron. Okay, and at the same time you have electrons that rotating around here. Okay, and the mass of electron normally is very small compared to the mass of the nucleus. So for an atom, most of the mass comes from the nucleus punya mass. Okay, so we have this kind of apa orang cakap symbol that we use to represent certain element in chemistry. So A here represent the mass number, Z here represent the atomic number of proton. Okay, so you have an equation like this where the mass number is equals to atomic number plus neutron number. So they might give you A and Z and you can find the N straight away. So if I go back to this diagram, neutron is the one that is inside the nucleus. Okay, so inside nucleus you have two elements lah, proton and neutron. And how do you want to determine the numbers of those neutron? You can use this equation. Because this one is given in the question, so you can subtract lah, mass number with numbers of proton so that you can get numbers of n. Okay, so far ada soalan ke tidak?
Tak ada sir.
Tak ada. Okay, so the problem is you have mass of proton and mass of neutron inside a nucleus like this kan. So individually, proton has a certain mass, a constant mass lah. Dia ada satu constant mass. And neutron pun ada satu constant mass. The problem is when they add up all the proton and neutron punya mass individually, the mass is not equal to the mass of the nucleus. Dia tak sama. So ada difference. Contohnya kan, kalau saya ada Lego. Okay, let's say kamu ada piece of Lego. Contoh, Lego yang mainan kecil tu kan. So katakanlah satu ni berat dia 2 gram. So you have 3 of those. So if you measured this one separately, total mass would be equals to 6 gram. Which is logic lah. Satu tu 2 gram, darab 3, you get 6 gram. But the thing is, when you combine these three, supposedly you still get 6, but you get something less than 6. So ada mass yang hilang. So ini dalam bahasa yang senang nak difahami lah. So should be 6, but there's a loss of energy. Tapi there's a loss of mass. Tapi loss of mass tu bukan yang hilang lah. Dia actually tukar jadi energy. Ni saya nak bila ni. Okay, so if you look at the definition of mass defect, okay, the difference of mass tu, we call that one as mass defect. We represent with a symbol of delta M. Okay, delta M is a mass difference between the total mass of constituent nucleus, so maksudnya untuk individual nucleus, and the mass of a nucleus. So, inti dia tu bila kamu tambah tak sama dengan total. Itu maksudnya lah. Faham ke tidak? Can you guys follow me?
Faham, sir.
Faham eh? So individual tu tambah tak dapat semua. So you have we have an equation over here lah. So this equation sebenarnya kalau kamu tengok based on logic dia sangat senang nak difahami. So individual dalam nucleus tu you only have proton and neutron. Betul? So numbers of proton Z tu multiply with a single mass of proton and you add with numbers of neutron multiply with the mass of neutron. So you should get a certain mass. Okay, so basically this is the mass of constituent nucleus. Inti nucleus tu ini mass dia. Tapi if you minus with the mass of the nucleus, kalau kamu timbang nucleus itu, dia ada perbezaan. So this is the idea lah. So this one individual minus as a whole, you get the mass defect. Okay. Okay, this one is one of the clear example lah. So in this chapter, sometimes we use a unit of kilogram, sometimes we use a unit of AMU. So kamu belajar chemistry, kamu familiar kot with AMU ni. Okay, now the question are the mass of the subatomic particle are greater than the mass of nucleus. Contohnya kat sini you can see So individual proton, the weight is 1.00728. Individual neutron, this is the weight. So you should have 3 proton and 4 neutron, but the nucleus weight is this one. Okay, cuba kita kira berapa banyak beza dia. So if you want to check the mass defect, so we can multiply numbers of proton with the mass of proton, and we can add with numbers of nucleus neutron with the mass of neutron, and then we can minus mass of nucleus. Just check the symbol that you use. So this one should be 3 multiplied with 1.00728 plus 4 multiplied with 1.00866 minus 7.016005. So again, saya repeat numbers of proton multiply with individual mass of proton. This one is a constant. Plus numbers of neutron multiply with mass of neutron, which is a constant as well. So this one, mass of nucleus normally is given in the question. So to calculate mass defect, cuba tekan calculator. Kamu cuba buat ni. You guys do it at the same time with me ke saya buat seorang-seorang? Okay, one thing about this chapter, dia ada banyak nombor yang kecil. So kamu jangan bundarkan pula. Kalau dia 1.00728 tu, jangan kamu tulis 1.007. So I should get here is 0.04. Since we use AMU, so we should get AMU as well. Okay, understand or not? Any question?
Faham, sir?
Ada soalan?
Tak ada, sir.
Ada. Okay, kalau tak ada soalan, saya pula nak tanya kamu. So, mana pergi maths tu? So, kamu bayangkan kamu ada Lego tadi kan? Sepatutnya kamu dapat 6 gram, tapi timbang-timbang dapat 5.8. So mana lagi 0.2 gram tu? Dia hilang mana? Tapi Lego tak jadilah benda ni. Ini yang jadi. So kamu bayangkan, proton tambah, neutron tambah, dapat kurang daripada yang sepatutnya bila kamu timbang. So mana pergi mass tu? Kamu rasa lah. Adakah kena makan? Any idea? Any suggestion? Hello, adakah kamu bersama saya? Mana pergi mass itu? Teka je, salah tak apa. It's okay.
Energy release when forming the nucleus.
Sikit lagi. So dia sebenarnya memang energy it's because of the energy. So dia jadi cerita macam ni. So kamu ada individual mass of proton dan ada individual mass of neutron. So bila dia nak put together, dia required some energy. Macam gam lah. Macam something that hold this mass together. So the thing that hold this mass together is what we call binding energy. So binding energy dia tak boleh datang daripada tempat lain. So energy ni kena ada something lah. Energy kan cannot be created ataupun destroyed. Dia kena conversion daripada benda lain jadi benda lain. So in this case, the mass is actually converted into energy. Okay, so binding and our next subtopic is about binding energy. So what is binding energy? It is actually energy that required to break a nucleus into separate non-interacting nucleus. Interact region. So kamu boleh bayangkan lah, mass yang hilang tu sebenarnya digunakan untuk pegang dia punya proton dengan neutron. So that one convert into binding energy. So the formula is this one. So this is the formula. This one comes from the Einstein equation, which is E equals to mc square. Apa saya buat tadi? So where E is equals to mc square, tapi instead of m, kita ada delta m lah, which is the defect of mass tu, multiply with speed of light, and you should get the energy. So perlu ke saya tulis? Saya tak boleh tulis kot. C square over here is 3 times 10 to the power of 8 if you use SI unit. So if you use everything in SI unit, contohnya mass in kilogram, then you can calculate EB to be in joule. Okay. So that one is the energy that is holding the proton and neutron. So obviously kalau kamu nak breakkan, contohnya ini adalah dia punya EB obviously kalau kamu nak breakkan proton dengan neutron tu, kamu kena overcome EB punya energy. So this is what you call energy that required to break a nucleus. Okay, into separate non-interacting neutron. So the problem with this chapter normally is the unit. Okay, so you have multiple unit to use. Example over here is U, kilogram. So this is the unit conversion. This one is given in the formula sheet. Okay, so 1 EV is basically energy, which is equivalent to 1.6 times 10 negative 19 joule. And then most importantly, we have this one. I'm not sure whether this one is given uh, in the formula sheet or not. But this one is the formula lah. C square ni, you can represent C square in terms of MEV over U. Kenapa kamu nak pakai macam tu? So that delta M ni, you can straight away substitute in unit U. You don't have to convert to kilogram lah. If you want to convert to kilogram, then C square ni dia kena pakai 3 times 10 to the power of 8 and then you have to take square. Okay, but if you want to stick delta M with U, you can straight away substitute the numbers here and this number 931.5, and remember this one is square. Dia dah square siap-siap. So you don't have to square lah. Jangan kamu letak 931.5 square. Itu salah. 931.5 saja. Okay. So ada dua method to find EB. Dia depends on the given unit. Okay. Kalau katakan delta M in kilogram, kamu pakailah C tu 3 times 10 to the power of 8. Kalau delta M in U, you have to use C. You can use, it doesn't mean you have to. You can use C square 931.5, but final answer mesti dalam MEV. Okay, maybe I can write it one more time so that you get the clear idea of this one. What does it mean by that? So if I use EB in joule, that means my mass will be in kilogram and my C is in ms minus 1 square. Okay, let's say if my EB is in MEV, then I can use my mass in U and C square as my 931.5 MEV over U. Okay, you don't have to square. Dia dah square siap number tu. Okay, ada soalan tak?
So, memang tak boleh cari joule dan darab untuk convert.
Boleh, tak ada masalah. So kalau kamu pakai SI unit, basically kamu pakai SI unit lah, this one. Kalau kamu dapat dalam joule ni, kamu still boleh tukar kepada MEV, tak ada masalah. Okay.
Okay, faham saya.
Menjawab soalan tak? So maksudnya kat sini, it depends on the unit that is given and the unit that you want to choose. Kalau kamu memang nak stick kepada SI unit, so you change everything to kilogram and you use constant of 3 times 10 to the power of 8. So final answer mesti dalam joule dan semua SI unit. Alternatively, because chapter ni biasa dikasih dalam U dengan dia nak cari dalam MEV, so you can use this formula straight away. Kalau tak biasa, convert je lah. U yang diberi tu convert pada kilogram and then you can substitute inside here instead. Okay, next one is binding energy per nucleon. Tadi binding energy, this one is binding energy per nucleon. So basically just divided by numbers of n dia sebenarnya. Mana saya punya? Okay. Okay, it indicates the stability of a nucleus. So the higher the binding energy per nucleon means more work required to remove nucleon from the nucleus. Formula dia okay. It's basically just have to divide by the nucleon number. So EB over A is basically EB over A lah. EB tadi tu delta M C square, tak kisahlah kamu nak pakai MEV ke apa. Then it is divided by numbers of nucleon. So this one is nucleon number. Mana datang number nucleon ni? Kalau kamu tengok balik, dia dekat atas ni. Okay, nucleon number A tu. Okay. Okay, later on kita akan cuba buat example lah. But for now, step dia sangat mudah. So, biasanya macam tu lah. Dia biasanya suruh kira binding energy. So bila dia suruh kira binding energy, you have to find the mass defect first. My suggestion is that you do it separately lah. Okay. So once you have yang ni saya tak cukup tepat bahan. Okay. Once you have the mass defect, you can take this number and you can substitute inside this equation to find the binding energy. I suggest you to do separately lah. Letak M2 separate dengan EB so that you can still get the mark over here kalau salah yang bawah. And then one more thing is that please jangan round off the number too early. So macam saya tadi tu, kalau kamu round off, dah kena memang lari. Biasanya kalau AMU ni biasanya 6.40-an. To that extent lah. Tulis je number dah. Okay, and then the last part dia akan tanya pasal binding energy per nukleon tu. So that one just divided by numbers of A. Biasanya soalan dia tu macam beranak-anak. So itu soalan terakhir je lah. Okay, in terms of stability, okay, you have a graph of against the mass number A. Okay, this part, okay, supposedly the numbers is small. Dekat sini kan di bawah. So dekat sini biasanya stability dia rendah. Over here pun rendah. The maximum stability is over here. So dia yang rendah tu dia tak nak fokus sangat lah. Dia sebenarnya nak fokus the greater stability ni. So this is the region where you should have a greater stability. So one of the most stable element is nickel, and then we have ferrum, and this is copper. Okay, so nucleus with a high binding energy normally in the region of 50 to 80 mass number then. Okay, for those yang low here, maksudnya dia tak stable. And bila dia tak stable, dia ada tendency untuk decay kepada yang lebih stable. Itu kita akan belajar dekat radioactivity in our next subtopic, which is today kot. Tapi this is the idea lah. Once dia dah dapat greater stability, dia memang stable. Okay, dalam kalau kamu tengok nota kamu tu ada certain nota tambahan. Contohnya hydrogen zero binding energy because it has only one nucleon. So ada macam-macam lah. That one you can read it yourself. Okay, ada soalan tak so far?
So so good, sir.
So far so good. Okay, kalau okay, maybe kita boleh try tengok one of the example. Okay, we start with question number 6. Oops, apakah ini? Okay, can you see the question clearly? Ke tak nampak? Nampak tak soalan dia?
Yep, can
Yep,
see
okay.
clearly.
Cuba kamu baca dan cuba kamu buat. Kamu ada helium. 4 and 2 is the isotope of helium. Its mass of nucleus is 6.6447 times 10 negative 27. Calculate its mass defect. Saya buku tutorial. Okay, kalau soalan macam ni, dia beri dalam unit apa? kilogram kan. So yang 6.6447 tu sebenarnya apa? Dia punya apa? Ni mass apa? Kelas. Ni mass apa?
U.
U. Okay. Ini adalah mass of nucleus. Okay, if you guys still remember the formula for delta M, soalan dia sebenarnya nak cari calculate its mass defect. So if you want to calculate mass defect, you have to use formula of delta M equals to numbers of proton multiplied with proton punya mass plus numbers of neutron multiplied with mass of neutron minus mass of nucleus. Okay, so the given information stated over here is mass of nucleus. So that one is the mass of nucleus lah. Calculate its mass defect. So they want to find delta M. You already have mass of nucleus. They didn't give you directly MP and MN, but that one you can get in the formula sheet kamu tu belah depan kan. List of selected constant value. Kalau dalam example sama dia belah depan tu. Cuba kamu tengok dalam buku nota kamu, buku tutorial kamu tu, list dia tu, berapakah mass of neutron dengan mass of proton.
One point 672.
Okay, so kalau kamu tengok nombor dia, dia ada dua kan, 1 kilogram, 1 U. So kalau mass yang dekat belakang tu dalam kilogram, obviously you want to use everything in kilogram lah, so you don't have to convert anything. So mass of proton is actually 1.672. And mass of neutron is actually equal to 1.674. Tolong pakai semua nombor tu sebab kalau kamu tak pakai nanti jawapan dia lari. And constant ni you don't have to memorize sebab sometimes certain year dia kasi 4 tempat puluhan, sometimes dia kasi 3 tempat puluhan, so you have to use the one that is given lah at that year. Okay, so numbers of proton and numbers of neutron, how about those numbers? So you know that this one is, we are talking about helium that has 4 and 2. Okay, if you go back up here, oops, 4 to actually represent A and 2 is represent Z. So yang 4 tu sebenarnya adalah A and 2 tu adalah Z. Okay, so Z tu you can use this number and you can substitute straight away lah, tak ada masalah. Z over here 2. Okay, sekarang ni N saya berapa?
2.
2. Macam mana kamu dapat 2?
4 minus 2.
Yes, exactly. So you know that kalau ikut equation yang kat sebelah atas tu, A is equals to Z tambah N. So you already have numbers of A dengan Z tu ada. So you minus dia lah so that you can get numbers of neutron. Okay, so this you just have to press your calculator. Okay, make sure you press all the numbers that is written over there. Jangan malas tekan, jangan kurang satu nombor pun. I got here is 4.73 times 10 negative 29. Okay, so basically this is the mass defect, the difference of individual, the sum of individual proton and neutron with the nucleus punya mass. Okay, any questions so far? Soalan tak?
Rasanya tak ada.
Okay, kalau tak ada kita cuba buat lagi satu soalan. Okay, oops. So kita tengok question number 7 pula. Okay, you're given the mass of nucleus PR, the barium code is 80.8971 U. Calculate the binding energy in unit MeV and unit joule and binding energy per nucleon in MeV and E joule. Okay. Okay, so you're given 81 dengan 35 tu. Yang 80.8971 tu mass of apa?
M nucleus.
Yes. Okay. So 81 ni 35 ni apa?
A dengan Z.
Yes, A dengan Z. Tapi A kita tak masuk dalam formula pun. So saya dia highlight this one. Okay, yang 35 tu adalah numbers of proton. Z. So now I can find my numbers of neutrons straight away. So N is equals to A minus Z, which is 81 minus 35. So get 46. Okay, this is numbers of neutron. So I think by now you get all the information needed. You want to calculate binding energy in unit MeV and in unit joule. So obviously we can find EB equals to delta MC squared. So the first step is to find delta M first. Obviously you can straight away calculate EB sama dengan delta MC squared, tapi suggestion saya cari delta M dulu. So to find delta M, the formula is simple. Numbers of proton multiply with mass of proton plus numbers of neutron multiply with mass of neutron minus mass of nucleus. Okay, so if you want to solve this one as fast as possible, as quickly as possible, you want to use which unit? Kau nak pakai U ke kilogram?
Pakai U.
Pakai U kan, sebab inilah mass of nucleus pun dah dalam U. And then untuk mass of neutron dan mass of proton tu sebenarnya dalam formula sheet pun ada U. So that's why kita pakai U. To solve this one is 35. Again, nombor MP ni jangan hafal sebab kadang-kadang dia berubah. 1.007277. Okay, plus 46 1.5 0.08665. Double check, make sure you didn't left out any numbers. Macam okay. And then minus 80.8971. Agak over here is 0.756185 U. Okay, again, you don't have to round off. Tak payah round off, biar je macam tu. Okay, the next one, obviously you want to calculate EB. So your EB is equals to delta M C squared. So you already have values of delta M, which is 0.75618. The one is in U. So you want to multiply with C square. C square ni kamu nak pakai nilai apa? 3.10/8 ke? Ataupun yang 931.5. Macam ni kan? You want to use this value or you want to use this value? Which one?
Apa sih soalannya?
Okay, soalan saya, kamu nak calculate EB ni kan? EB sama dengan delta MC square. So, you substitute values of delta M. Now, you want to substitute values of C square tu. So, kamu nak pakai dalam unit MEV ke dalam unit meter per second tu? Macam ni. Kiri ke kanan?
MEV. Kanan.
Yes, MEV. So, kalau dalam U, kamu pakailah yang belah kanan ni. And then, you should get the answer straight away. So, 931.5. Sebenarnya 931.5 tu ada dalam formula sheet juga. So, you don't have to memorize anything. As long as you know when to use. 931.5 MEV over U. Okay. Kat sini saya tulis unit dia ni sebab nak help you guys to understand lah dia punya final unit dia. Tapi dalam exam, you don't have to write the unit every single time. Final answer dia tulis unit. So over here, I got 70439. Okay, now you can round off. Kalau yang math tu, yang jangan round off. The unit will be MEV. So you can see the clearly lah where does the MEV comes from. Okay. Common mistake, student letak square kat sini. You don't have to take square because this one is the values that already squared. So dah ambil square. Okay, any question? In fact, kalau kamu, yang ni saya tulis unit. Kalau kamu tak nak tulis unit, dia 931.5 C square darab C square contoh lah. Tapi biar je lah. Saya buat macam ni. Okay, ada soalan ke tidak?
Tak ada sir.
Tak ada. Okay, now the question we to find in MEV and in joule. So now your job is to convert this value to joule. So if I want to convert, the first thing that I can remove is the mega. Prefix mega tu, which is equals to 1 times 10 to the power of 6. So you can do that, but you still get your final results in EV. But if you want to convert EV to joule, you have to multiply with berapa? Macam mana nak convert EV to joule? Lupa dah.
1.6 times 10 to the power of negative 9.
Correct. You have to multiply with 1.6 times 10 negative 19. Okay, if you do that, you should get your final answer in June. You got 1.13 times 10 negative. Okay. Oh, so lupa darab dengan mega. 10 negative 10. Then the last question, actually they ask to find EB per nucleon. So EB over A. Okay. A here, from the given element symbol ni, you know that A is equals to 81. So this one becomes, dia pun nak dalam MeV, so you calculate MeV first. 704.39 divided by A, which is 80, apa tadi? 81. 81. So it's 81. And you should get 8.70. Okay, unit dia ada per nucleon. And then if you want to calculate in joule, you can either convert this one to joule ataupun kamu boleh buat balik. Tapi start daripada joule, which is 1.13 times 10 negative 10 joule tadi tu divided by 81. You get 1.40 times 10 negative 12 joule per nucleon. Okay, ada soalan? You guys understand?
Apa sih?
Faham sih.
Faham Okay, so chapter ni dia tak susah, especially for this subtopic lah. Dia memang tak susah. And dia cuma masalahnya calculation tu ada banyak numbers. So kamu kena careful kat numbers tu. And jangan square yang 931.5 tu. Memang selalu sangat student square. And then 3 darab 10 kuasa 8, jangan lupa nak square. Tu masalah dia. Kalau yang 3 darab 10 kuasa 8, you have to take square. Kalau 931.5, you don't have to square it. Soalan ni biasa senang, straightforward, and sepatutnya tak ada masalah. Okay, so kalau tak ada soalan, kita berhenti sini dulu. Then okay tak? Maybe stop here.
Boleh sih?
Okay, thank you everyone.
Thank you, sir.
Okay, sir.
Alright. Okay,
Thank you sir. Assalamualaikum.
salam.